Hey guys, hi and welcome to the video. My name is Saumil Shah. I work as a software engineer, and in this video, I'm going to be sharing a very important concept about Elasticsearch. Essentially, how to stress test your Elasticsearch cluster or an index for optimum speed. Which means, are you expecting? Are you essentially, is your Elasticsearch cluster a little slow? Which means, what I'm trying to say is, say you have an index and the performance is very slow on that index. How do you optimize it? How do you essentially identify what's causing that slowdown, right? How to choose that optimal number of replicas, how to choose the optimal number of shards. Well, this video is all about that, right? I used an open source software called Apache JMeter to stress test Elasticsearch index, and here are the results that's gonna blow your mind. Before that, I would like to show you the approach on how anyone should do that, right? So if you are new, well, this video will provide you an overview on how I did that, right? So I essentially created a test plan. Then I essentially had a thread group, which means users, right? Then what I did is, and these are just a sample number, but I'll actually show you the data. So point one has a ramp up time over here, which means every 0.1 second a new user is added. Total users are 100. They are hitting the Elasticsearch cluster. Then 0.4, 0.1, and so I kept on changing this parameter, and I kept on taking what's the average time it is taking for the search, right? So I did an aggregate report. I did that, right? And I kept on changing this. After that, what I did is I also did for various shards. So I created a new index. I re-indexed my data with 20 shards, 40 shards, 10 shards, and then I essentially plot all the response time on Excel. Once I have the Excel, then let me show you the results, which is gonna really blow your mind. So let me expand this, and then we can talk a little bit more. So as you can see here, this graph essentially, the x-axis represents the ramp-up time, and the y-axis represents, so the y-axis represents the average time it took for that query. I essentially downloaded some sample data set around 10 to 15 million data points on my local machine, and did some stress testing. So after doing the testing, what I really observed was for essentially 100 users, right? The data point was massive, right? So for essentially 100 users, right? For 100 users and for 20 shards, it was taking this much time. The blue line that you see right here, right? Now, what you will observe very interesting is the orange line. As I decrease the number of shards, I really obtained a very faster speed. So essentially, at this point, that is 0.2. I'm not sure if I can take a pen here, but is there a pen here that I can use to explain you guys? That would be really nice. Draw, maybe let me try this one. Okay, so a very interesting point was at this point, right? So as you can see here, by decreasing the number of shards, I was able to obtain an optimal speed. I was able to get the speed part nailed out, right? So because usually remember on an average you want to have around 15 to 20 gigabytes per shard, right? So if you're randomly just selecting a shard, that you're not gonna achieve optimal speed, which is why I said, right, you want to do this exercise, you want to do the JMeter test, and then essentially, as you can see here, right, I did that on my local machine. I had a sample query, right, a get request. This is the sample data set that I was hitting, right, for 20 shards, for 10 shards. I did all this testing, right? I did all the results, and then I'm explaining you. So essentially, since I decreased the shard, I was able to get much more faster speed on my Elasticsearch cluster. As you can see, the ramp up time increases. The ramp up time means the user are coming after that many time. So here, every 0.2 second a new user is coming, every 0.4 second. So I did this variable test, right? Then I recorded the result. So one thing you gotta understand that a lot more number of shards are not going to help you to increase the speed, because then if you have a lot more shard, the data essentially, let's say you have 1, 2, 3, 4, so data has to go through this shard, this shard, this shard, this shard, and has to wait, right? But if you have an optimal number of shard, you can really get an amazing performance boost on Elasticsearch. So this is one thing that you need to really understand. That the next set of results will really blow your mind again, as I said. Hopefully if I can show you. Okay, this graph right here on the x-axis, it represents essentially the ramp-up time, which means a new user has been added. The y-axis is the average response time. The blue line that you see is essentially 10 shards, 1 replica, and similarly, the orange line that you see is 2 replicas. So now I increased the number of replicas. So now this is really amazing to see here. So for 0.01, 0.1 and 0.2, which means when you have massive amount of read requests, As you can see, more number of replicas helps you to gain a faster speed. Again, let me repeat that. If you have lot many concurrent user to serve on Elasticsearch, more number of replicas will help you. But you want to do this JMeter test, you want to do all these tests and then come to a conclusion, right? So as you can see here, at a time, increasing replica for massive amount of user, it was helping me to achieve a faster speed. But as the time goes on, right, if less number of users are hitting, it doesn't really matter, right? It's almost same, as you can see both of them over here. After this point, 0.4 second, it's almost same. But if you have a load which is between this range, right, then you want to increase the number of replica, which is why I said, guys, you want to do these tests, right? It would take time. I know the reindex will take time. The shrink will take. You want to use the shrink API. You have to do all this. It would take time. But once you have these optimum result, then speed is gonna be amazing. You want to have these tests done. Now, a very, 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 very interesting test that I also performed was ramp up time versus response time again. This is for 20 shards, right? So this one was for 10 shards. We know that decreasing shard gave me a good speed, right? Then I said, okay, well, let me see if increasing replica has a effect on that, right? Then I said, okay, let me do for 20 shards then. So if you observe here, so the orange line is 2 replicas. Okay, so orange line is 2 replicas. The blue line is essentially 1 replica. So I said on 20 shards, we knew that number of shards were more, so it was not giving us performance, right? So I said, okay, if I have more number of shards and if I increase replica, is that gonna help me or is that gonna deteriorate my performance? So after doing the test result, the results are amazing, man. So as I said, the orange lines is 2 replica. At this point, as you can see, it does not really help. To a certain extent, yes, for massive amount of traffic, yes, replicas will help you. But as you can see, the difference is not more, right? So what I'm saying is if you have more number of shards, right, and then if you try to increase replica for your speed, not gonna help you guys. So which is why do all these tests and this is gonna help you to achieve optimum performance for your Elasticsearch, right? Now, how do you do all these tests? I'm not gonna go much in detail, but okay, I will tell you the concept. So say you have an index, let's say sample data set you have, right? So if you want to increase the number of shards and replicas and you want to do all these tests, guys, always use the shrink API. Now, the problem with shrink API is, let's say you have 20 shards, you can go in the multiple of that. So you can reduce to 10 and 5. You cannot make 4, you cannot make 7, 9 odd numbers. No, then you have to use a reindex API, which is why start with a very big number of shards and then try reducing the number of shards using shrink API and not the reindex API. I have made a video where reindex API is much more expensive than doing the shrink API, right? This video will provide a very beautiful insight about shards and replicas on Elasticsearch, how I essentially used Apache JMeter to do all this testing. So you can essentially do test with your aggregation queries and different parameters, plot the result out, and then you can decide, okay, this makes sense. I want to use this one. This is why at this particular setting, at this shard, this replica, it's going to give me the best performance for these many users. That's how you want to do it, guys. Okay, with that being said, hopefully if I can turn my camera on for a second. Let me see my camera. All right, I'm back. So hopefully you really enjoyed this beautiful insight about tuning in Elasticsearch, right? Here, your concepts about sharding, replicas, a reindex API, shrink API, you might have to use aliases because when you do all these testing, you'll be creating new indexes, but you want to make sure that your whenever you do all this, you don't want to have any downtime or stuff like that. So you want to create alias to your new index. Every time you do all these, you want to learn all these concepts in Elasticsearch is what I'm trying to say. Hope this results blew your mind and you had amazing insights on Elasticsearch tuning. With that being said, thank you so much for watching. If you have any additional questions, let me know in the comment section below. I would be very happy to help you out, or maybe if I don't know, I'll learn myself and let you know. With that being said, keep smiling, keep programming, and I would see you guys in the upcoming next video.